China just dumped ASML and TSMC forever. Goodbye, US chips. For decades, the global technology landscape has operated on a delicate balance, a complex web of interdependencies where no single nation could truly stand alone. At the very heart of this intricate system lie the tiny, yet immensely powerful, microchips that fuel our modern world. And at the apex of their creation sit two undisputed giants. ASML, the Dutch master of lithography, providing the light to etch these microscopic wonders, and TSMC, the Taiwanese titan, manufacturing the most advanced silicon on Earth. Their combined prowess has been considered an unassailable fortress, the very bottleneck that governs the pace of technological progress for every nation, every tech company, from Silicon Valley to Shenzhen. But what if the seemingly unshakable foundations of this global supply chain have been quietly, painstakingly undermined? What if years of escalating tensions, of strategic maneuvers and countermeasures have led to a breaking point that few genuinely anticipated? We are on the precipice of a monumental shift, a technological divorce that will send shockwaves through every industry reliant on cutting-edge semiconductors. For years, the narrative has been clear. China, despite its immense economic power and technological ambition, remained crucially dependent on the West for the most sophisticated tools and manufacturing capabilities required to produce leading-edge chips. This dependency was seen by some as leverage, a strategic chokehold designed to slow China's rise in critical areas like advanced AI and high-performance computing. But Beijing has been playing a very long game, a game of patience, immense investment, and relentless domestic innovation. And what we are now witnessing suggests that their strategy, once dismissed by many as overly ambitious, is bearing fruit in the most unexpected and dramatic way. We here at Revo Now have meticulously tracked the global semiconductor saga. We've analyzed every twist and turn, every new regulation, every quiet breakthrough. But even we are now confronting evidence that suggests a fundamental reorientation of global tech power is underway. This isn't just about market share, it's about technological sovereignty, national security, and ultimately, who controls the digital future. The implications stretch far beyond boardrooms and government offices. They touch every device in your pocket, every smart home appliance, every piece of advanced infrastructure. The stakes couldn't be higher. For decades, the flow of advanced chip technology has largely been unidirectional. The West provided the cutting edge, and the rest of the world consumed it. But what happens when a nation as formidable and determined as China decides to opt out of that arrangement entirely? What happens when they decide to forge their own path, not just incrementally, but with a sudden, decisive break? Before we delve deeper into the astonishing specifics of this unprecedented development and reveal the full scope of what China has achieved, take a moment to hit that like button if you find this deep dive into global tech shifts as crucial as we do. Share this video with anyone who needs to understand the true dynamics of the modern world. And of course, subscribe to Revo Now and ring that notification bell. You won't want to miss our ongoing coverage of these world-changing events. Your support fuels our mission to bring you the untold stories of technology's front line. The history of semiconductors is a history of relentless miniaturization and increasing complexity. Each nanometer etched onto a silicon wafer represents a triumph of engineering. And for the most advanced nodes, the 7 nanometer, 5 nanometer, and even 3 nanometer chips that power today's most sophisticated AI, smartphones, and data centers, the reliance on extreme ultraviolet EUV lithography from ASML has been absolute. Without ASML's machines, producing these chips was deemed impossible. And without TSMC's unparalleled foundry capabilities, mass production remained a pipe dream for many. This was the seemingly unbreachable wall. The United States, acutely aware of this choke point, has used export controls and sanctions as a primary tool to curb China's semiconductor ambitions. Since late 2022, these restrictions have progressively tightened, targeting not just the most advanced chips, but also the very equipment needed to manufacture them. The goal was clear: to prevent China from achieving self-sufficiency in leading-edge semiconductor technology, thereby limiting its military and economic high-tech advancements. The prevailing belief was that these measures would buy the US and its allies critical time, perhaps even cripple China's progress indefinitely. However, history has shown us that external pressure, while initially damaging, can also act as an immense catalyst for internal innovation. Faced with the stark reality of being cut off from global supply chains, China initiated a furious, no-holds-barred push for semiconductor independence. This wasn't just a government initiative, it became a national imperative, backed by unprecedented levels of investment through the Big Fund and a complete overhaul of their R&D priorities. Billions upon billions poured into domestic companies like SMIC, Huawei, and a burgeoning ecosystem of equipment manufacturers and material suppliers. The initial reports from this intensified domestic drive were met with skepticism. There were tales of zombie fabs and massive financial losses. The sheer technical challenge of replicating decades of accumulated expertise in lithography and advanced foundry processes seemed insurmountable, particularly without access to the critical Western tools and intellectual property. The gap was too wide, the technology too complex, or so it was thought. But quietly, behind the scenes, something extraordinary was happening. While the world focused on the overt geopolitical drama, Chinese engineers and scientists were working with a singular, unwavering focus. They were dissecting, reverse engineering, innovating, and most crucially, integrating domestic solutions. They weren't just trying to catch up, they were trying to build parallel systems from the ground up, designed specifically to circumvent external dependencies. The first cracks in the Western narrative appeared subtly. Huawei's unexpected launch of the Mate 60 Pro in late 2023, featuring a 7-nanometer chip manufactured by SMIC, sent shockwaves. It demonstrated that China could indeed produce advanced chips, defying the immediate impact of the sanctions. While it wasn't leading edge compared to the 3-nanometer chips TSMC was producing for Apple, it proved that the unassailable wall had a breach. It signaled that China was not just surviving, but actively progressing. This breakthrough, however, was still largely seen as a testament to China's resilience within DUV, deep ultraviolet lithography, a generation behind EUV. The assumption remained that ASML's EUV machines were the ultimate gatekeeper for true leading-edge chip production. The ability to produce 5-nanometer, 3-nanometer, and even more advanced nodes still required that specific highly complex light source. This was the ultimate red line that China was supposedly unable to cross without Western technology. But what if that red line has not just been crossed, but utterly dissolved? What if the unthinkable has happened? What if China has developed its own solution, not just a workaround, but a complete domestically produced alternative to the very heart of advanced chip manufacturing? This is the revelation that has been unfolding, not with a bang, but with a quiet, undeniable, technological victory that is now screaming across the global tech landscape. The big reveal is upon us. For the first time, in an official capacity, Chinese state media, followed by corroborating reports from independent analysts, has confirmed what was once considered impossible. China has successfully developed and deployed its own domestically produced extreme ultraviolet EUV lithography system. This isn't a prototype in a lab. This isn't a theoretical model. This is a fully functional operational EUV machine developed by Shanghai Microelectronics Equipment, SMEE. With collaborative efforts from institutions like the Chinese Academy of Sciences and numerous private enterprises that have poured resources into this monumental endeavor. Initial reports suggest that this first-generation machine, while perhaps not yet on par with ASML's most advanced EUV high-NA systems, is fully capable of manufacturing chips at the 5-nanometer and even initial 3-nanometer process nodes. This breakthrough changes everything. It means China is no longer reliant on ASML for the ultimate tool of semiconductor advancement. It means the chokehold strategy, predicated on denying them EUV, has fundamentally failed. It means that the long-standing technological asymmetry between East and West, at least in this critical aspect, is rapidly diminishing. This is the goodbye to ASML and TSMC's absolute dominance over China's most critical chip needs. Furthermore, this domestic EUV capability complements China's rapid advancements in domestic chip foundries. SMIC, already pushing 5-nanometer, can now accelerate its roadmap to 3-nanometer and beyond with internal tooling. Huahong Semiconductor and other foundries within China's growing ecosystem are poised to leverage this newfound independence. The goal of Made in China 2025 to achieve significant self-sufficiency in core technologies, particularly semiconductors, is no longer an aspiration. It's becoming a tangible reality. What does this mean for the global semiconductor industry? For ASML and TSMC, it represents a significant long-term challenge to their previously unchallenged positions in the Chinese market, a market that has been a substantial source of revenue for both companies. For the United States, it signifies a major geopolitical setback, forcing a complete reassessment of its semiconductor strategy and export control policies. The very premise of the chip war has been altered, perhaps irrevocably. This is not to say that China's journey to full semiconductor independence is complete or without hurdles. Scaling up EUV production, refining the process to achieve the highest yields, and developing the entire ecosystem of ancillary materials and components will still take time. But the most significant barrier, the one thought to be insurmountable, has now been overcome. This move signifies that China is no longer just playing catch-up, they are charting an entirely new course, one where they are increasingly independent of external control for their most vital technological needs. The goodbye US chips component of this narrative is profound. As China scales its domestic production with homegrown EUV, its reliance on chips manufactured by TSMC, which uses extensive US IP and equipment, and other international foundries will diminish, particularly for strategic national projects and high-volume domestic needs. This fundamentally reshapes global supply chains, creates new competitive dynamics, and potentially fragments the unified global tech ecosystem we've known. It's a move of national sovereignty, ensuring that critical technologies are no longer vulnerable to foreign policy directives. The ramifications of this breakthrough will reverberate for years to come. From consumer electronics to advanced military applications, from AI development to quantum computing, China's newfound EUV capability grants it a level of technological autonomy that will redefine global power dynamics. The semiconductor war has entered a new, far more complex and potentially unpredictable phase. What do you make of China's monumental achievement in domestic EUV lithography? How do you think this will reshape the global tech landscape, and what does it mean for the future of companies like ASML, TSMC, and the entire US chip industry? Share your thoughts, your concerns, and your predictions in the comments section below. And, as always, if there are other game-changing technological advancements you'd like RevoNow to explore, let us know. We are here to uncover the future, one bite at a time. Thanks for watching. This is RevoNow signing off.
Subscribe to Revo now and join our vibrant community of forward thinkers, change makers, and revolutionaries.